voices. Very good afternoon. Thanks.
Good afternoon, sir.
How's the learning?
Yeah, fine. Your sound, sir. Yeah.
Good afternoon, all. Am I audible?
Good afternoon, sir. Good afternoon, all the participants, guests, chief guests, and Sir Harlal Singh, sir, Dr. Rahulrajchoudhary, sir. Yesterday, we had a great session on design thinking with Professor Harlal Singh, sir. Now, we will continue this session. Now, I call Dr. Rahulrajchoudhary, sir, to welcome. The microphone of Dr.
Dr. Uddhav, can you confirm my audio?
Sir, you are audible.
Yes, sir. You are audible and
Yes, you are audible, sir.
please.
Thank you.
I request Professor Harlal, sir, to start the session.
But Uddhav sir, I am not getting your audio, in fact. Yeah, please unmute and speak something.
Yes, sir, you are audible.
All right, you are also audible, but was someone else speaking? He or she was not audible. That may be the case. So shall we start then?
Yes, yes, sir.
All right then. Thank you very much. And hi all. We are meeting again. Good afternoon. And just recollect that we were into the concept of design thinking with some case studies. We were trying to understand the concept of design thinking. Okay, so if I look at this, the famous sketch of ours, what we wanted to know, some kind of the five steps initially: empathize, analyze, then ideate, solve, and finally test. So EAIST, something like that. So, but what we have done, just to make it very, very simplified, what we did is we went for a term called EAST, 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 something like that. Some issues with my pen. Anyway, so E is the most critical element here, which we talked in previous class also. A is again analyze, and finally S is the solve. S is solve. So solve, we have two terms for solution in the above sketch here. One is ideate and second is ideate, and second is proto. I think I have written here wrongly. It is prototype. Proto. So ideate and proto is combined. So they are all iterative steps. That means you empathize something, make all elements of the problem, and then you try to analyze. What analyze? Not the solution, but the problem analysis. So these two are very, very important together. It is more like anybody follows the Buddha's four principles of Buddha. What are those? We were taught during our social sciences. So will anybody like to tell me which are the four noble truths of Buddha? Anyone? I'm looking for your chat. Four noble truths. First one is dukkham, right? First one was sorrow or pain. Please tell me others. Other three elements. Anyone? Buddha says there is the first thing. The world is full of dukkham. So pain. Pain is first. Then what else?
Gain is last.
Sorry, pain is first and what is last?
Gain is last.
No, sir, it is not. Buddha's principle. Buddha's principle. Four thing. Just you can Google. I'll wait for a few more seconds because we haven't spent. Just Google and tell me, anybody. Buddha's four principles. First, he says the world is full of sorrow. You know the story of Buddha? Before Buddha, he was Siddhartha, the famous prince. And when he was born, I think we know the story of it, that when he was born, one noble person told that either he will be a great emperor or he will be a great sage. Sadhu banenge hain to raja banenge. So what his parents did, they kept him away from all those worldly pains. He never saw anybody dying. He never saw any poverty. But only by incident, when one day when he was a young charming prince with his wife and two kids also, he was traveling somewhere. He met somebody. He's on the way. He saw poor people, sick people, and then even people dying. And then he came to the conclusion, and the famous story, he left his kingdom in midnight and then went for enlightenment for years and years. And so after that, he gave four principles. So now please, I'm sure you must have text by now, Googled by now. Which are those?
Sir, first is life is full of suffering, and second
So-
is suffering is caused by ignorance and selfish desire.
So first
And
is
third one
suffering.
is
Suffering is, and the
yes, sir.
second is desire. That means there is
Yes,
some
sir.
reason for that suffering. So second
Exactly,
is
sir.
desire. Very good. Third one is
When ignorance and craving are reduced, suffering is reduced.
so there is some solution for that.
Yes, sir.
Okay. And what about third one?
Actually, this was the third one.
There are 4 clear paths.
Yes, sir. And the fourth is the way to overcome suffering is the path to enlightenment.
Way
Yes, sir.
means first is the suffering. Let us see as your good name, sir.
My name is Pushpendra Rajpurohit.
Rajgol Saab, just tell me. So let's make it S for suffering. Next
sir.
is
Desire,
ignorance.
sir.
Desire. Desire is second. The
Yes,
reason
sir.
is desire. Third one is
When ignorance and craving are reduced, suffering is reduced.
so what is that?
That is the solution.
Solution. There is some. So suffering, desire, and let us again
Solution.
go for S for solution.
Yes, sir.
There is some solution, but the solution may not be unique for the problem. Okay.
Yes, sir.
Let us see. And finally, it is
There is a way. The way to overcome suffering is a path to enlightenment.
path to enlightenment, or some kind of say last nirvana or whatever he said. Say let us see nirvana.
Yes, sir.
Okay. And we Hindu mythology we call it as mukti, or those words are there as per mythology. So these
sir.
are the 4 words that similarly related. Empathize. That means there is something like dukkha, those sufferings. Then sufferings have some reason, and those reasons are, say, analyze those suffering, their desire.
Yes, sir.
Then they can, the best part is that if you understand that, if you remove the ignorance, you can solve them. So there is a solution.
Yes, sir.
And finally, whatever solution you have found, you test that solution or finally relate that solution to your dukkha, and then get yourself nirvana or mukti or whatever way out, or you can get rid of the problem. So did you find it not interesting? The 4 words.
Exactly,
Four
sir.
words
It is
which
very interesting, sir.
the 4 words. So EAST we can relate it to Buddha's principle of, but the important part is just understanding those dukkha, those empathizing with the dukkha, empathizing with the problem, what we saw yesterday. Okay, so
Yes,
that's
sir.
why we have moved on to so these 4 stages only. EAST. Will you remember? Anyone?
Yes, sir.
Empathize, analyze, solve, and test. And please do understand this analyze, solution, and testing is also done for any kind of rational product made. Only difference lies in empathize. Okay. So now we know that. We also know that there is a product, excellent product called Jaipur Food. Since yesterday's class onwards, that this is a one of the disruptive product which has been made in terms of cost and its durability. It is not only the cost of the product, but it's one of the finest design you will see in terms of passive prosthesis, lower limb prosthesis. So these are the 2 things which you are aware. Now should we move on to what we can do is, if there is, this is finest product, then why at all we are discussing? We should तारीफ करें और छुट्टी करें, आगे चले, right? See, yesterday we praised the product so much. No doubt it is a wonderful product, but it was developed in 1969, 1968 rather, and then since then it has gone a long way, 50 plus years. So what has happened with those 58 years? What has happened during that time, 50 plus years? Let us understand that. And if there is a problem, we should again go back to this dukkha story or the empathize story, and then try to solve something. Okay, so if you solve something like Jaipur food or something which is, move on. So we are all set. If anybody has any question up to now, we can discuss, else we should move forward. Okay, anyone? So like yesterday, today also will be more into this interactive session, and more and more you are open to talk, and you are open to put your comments in the chat box. Will be more happy. But I'm sure, had I been a participant and it's 24 hours gone, I'll definitely have some questions in mind, and I'll put those questions before the speaker starts. So if you have any question, please do chat, so that we can incorporate those questions. It is not that solution is very important. The important part, if you are studying design thinking, and design thinking can be involved in everything, as you seen yesterday. So if we don't, at least in our teaching learning process, if we don't incorporate design thinking, we are not doing the right justice to it. So please come out with any kind of questions, put in your chat box, or if organizers permit, you unmute yourself and chat. No question? I was expecting some questions related to design thinking, those case studies which we talked yesterday. What Professor Sharma talked about design thinking can relate to. All right. Seems to be no question. So let's move forward. So will you remember? Say yes or no. This EAST, empathize, analyze, solve, and test. This theory of design thinking, or the process of design thinking. But you know that it is a mindset more than process, or along with the process, it is a mindset also. So we will be also talking about mindset. Okay, I'm not able to write by my pen today. Why so? Now it is writing. Okay, so you're talking the word mindset. And mindset relates to this word empathize, because yesterday we had talked about the difference between sympathy and empathy. How we as an Indian society are good in sympathy, but may not be that good in empathizing. So but if you have to incorporate design thinking, or if you genuinely solve some problem of the society, you should be focusing more on empathizing. Because whether you are a bureaucrat or senior IAS officer, or whoever maybe, or a student, a mentor, or a teacher, we cannot sympathize the student inside the class, but we have to empathize with the student. If I rightly say, do you agree with me? Say yes or no. So many of us are teachers here. So today I have brought some kind of content for scholars also, those who are in senior scholars, maybe like PhD scholars or MTech scholars. So if you think, we'll be able to relate it. So our idea is to empathize with the end user. End user can be the student, or maybe for whom we are interested in. End user. So it is like being the shoes of end user, the way we talked in yesterday's class, and then you try to be some useful of some kind of utility to the end user. All right. And should we, as an engineering professional, we should be, because yesterday I talked what engineers are supposed to do. They are supposed to inhale science and excel the social solutions or the technological solutions. That's what, every time you find a newer and newer product, newer and newer stuff for making life easy for those in the society. Okay, so now if you are okay with these terms called Jaipur food, if you are okay with the product, if you are okay with the fundamentals of design thinking, let's talk about this case study. And this case study talks about manufacturing standardization or some kind of problem if there is there with this particular product. We should talk about it first. So if somebody tells you that it's, say it was very good, say we can be proud of Indian culture. Do you agree with me? We are all proud of Indian culture. It's more than 10,000 years old since Vedas. But what has happened over a period of time? The system which were there meant for the well-being of the human being in society got corrupted. It got corrupted in systems like caste and the inequality and kind of even misbehavior towards women. So those things which were supposed to be a finest of the system got corrupted. That means anything which was we cannot live in the past glory. That's what I'm trying to say. The word here is we cannot live in the past glory. So the Jaipur food is excellent in design, but it has some problems. And once you have found some problem, then you have to go in deep, empathize with the person. Okay, that's the empathy means. So first thing to understand is we talked about empathy. So we moved on to we moved on to this study. What is this study? This word is very clear, very popular in these days, even with the corona studies and all those. Epidemiological study. That means what is epidemiological? It is a science of identify a disease or a pattern or a sequence. So even if you look at these professionals these days, they are of various types. Microbiologist for COVID, I am trying to say, epidemiologist, or then of course those clinicians who are treating the patients. So these are all one professional. So very similarly, this word is also talking about epidemiological study of this failure of the Jaipur food or why it is not able to last long or what are the problems. We wanted to do that study. Okay. So during that particular study, if you look at here, we found first why there are amputations. Why there are amputations in Indian society. So we tied up with a hospital in Jaipur called SDMH, Santokh Durlavji Medical Hospital, and then we did some study with those patients who were fitted with Jaipur food. And when we do this study, you just see there are a population of 100, which is not that great, but it is not low also. So out of this, we found that 65% of the patients or amputees were by traffic accident. This gives us lots of data. Then 10% by railway accident. Then there is a condition of the foot called gangrene. This is mainly to the diabetic patient. Then by birth, 3 cases. Congenital means by birth. Electric shock, 2%. 2 by cancer. Some gunshot by 2 by gunshot. Bomb blast, 1. Like transfer accident, 1. Thresher accident, no transfer. Thresher means agriculture accident, which have been reduced now. But construction accident is 1. Infection is 1. So this is the reason for amputation. And when you do this kind of study, you come to know this is done by not only, we published a paper also along with the doctors, but this is not this epidemiological study of the Jaipur flu. Now, when I look at what are the sequential things followed, qualitative damage, but this is one offshoot we went for. We wanted to see the failure of Jaipur food. When I look at the failure of the Jaipur food, we were trying to see what are the reasons from where it is failing, why it is failing, what is the region of discomfort. So we try to identify the ratings. So superficial failure, some minor crack has happened, or minor failure like this, or moderate failure, or severe failure. Okay, so these are the 4 categories were identified. So these are all 4 categories, and these ratings were done. Very similarly, the flow chart was made. Does the foot piece appear to be waterproof? If yes or no, because it is waterproof because of the nice superb design which has been done by Dr. Sethi, but it has some issues over a period of time. Moment the single crack comes, the waterproofing goes out. Okay, so that was done, and some data I will try to show. When you look at, we talked in the previous class, design of a Jaipur foot. It will have these many parts. So this is a wooden part, a metallic part, and 3 type of microcellular rubber components, and even a tire cord which has been wrapped, or finally skin color. When you look at this, these are different parts. But other than that, we found that, let us understand from where the failure has taken place. So identified various junctions. One was on the toes, whether the failure is taken from the toes or this forefoot block. This is heel block or hind foot, you can say, or was it on the junction? Failure is from the junction or from the ankle block or from, say, heel block. So what was the major failure was identified out of the 100 patients they were tested? It was the heel was the major reason, 42% out of 100. Means heel failure took maximum. Then was the forefoot, then heel and forefoot junction, HFJ. This is HFJ. Then ankle was some percentage, HAJ was some, toes were some. So this is another study which was carried out, and this can be referred under. Now imagine you are dealing with amputees, you are dealing with those people who have undergone trauma. One small even body language by you can be a catastrophic. You don't have to, they will not share anything with you, and they simply run away. So the important part is we need to relate to them, and that's what is empathy. This we have talked already, that this is the trauma, 87% trauma, right, in India's. Whereas in most of the developed countries things are different. Most of the European countries, it is a diabetic related cases are more in those world. Similarly, if you look at this particular study which was commissioned and which an objective. So what was the purpose of the study? To identify the etiology of the amputation performed. That means why they were amputated, how much time they have spent wearing, standing and walking with the foot, what are the reasons that the foot got failure, and most important, what are the frequent locations from where the failure takes place. If you understand these two, location and some kind of material related problem, you will be able to relate it and you will be able to solve something. Am I going good? So major thing happened for both this lack of manufacturing standardization. This is evident, it is published in literature. People say that across India or across world, there are hundreds of manufacturers of Jaipur foot. They even sometimes manufacture with different names. Somebody calls it Nisha foot, somebody calls it Madras foot, somebody calls it Ram foot, Shyam foot, whatever it is. That means there is no standardization. Another problem is this foot was manufactured 50 years back with a design keeping in mind the locally available material and locally available artisan. But now it is not the case. Both the cases are now not related because those artisans are not in short supply these days because it is not sustainable model. It is mostly supplied by government free of cost, right? And then these materials, as I told, the MCR and all are not available easily in market because footwear material has changed. Third thing, there is no standard way whether to manufacture in this way because people are manufacturing of their own without any standardization on it. So there is no control on the manufacturing of the Jaipur foot. Okay, because it is a kind of a cottage industry. So now idea is, if we can do something on this manufacturing standardization, it will be a good thing, because manufacturing standardization not only for the manufacturing process but for the material also. So we'll talk about some material, what material suits. There had been earlier attempts by materials like EVA, because modern day footwears are made by EVA or polyurethane. If you look at your shoes all these days. And the second is, it was being manufactured or still being manufactured by artisan community. It's more like a cottage content. So can we, without tampering into the design of the Jaipur boot, can we go for using contemporary manufacturing processes? Very important, because technologies has advanced in last 50 years in so many ways. Can those technological involvements or interventions can be involved here? Can we do something for increasing the overall quality of the food, the life of the food, and decrease its weight? So this is possible. The solution should be lying in manufacturing standardization. Can we provide a better product with higher sense of comfort? Of course, is the added advantage. Though it's originally it's a wonderful product, providing a better way of manufacturing and some kind of international quality or global standard, because if the design is so good, if it is rightly manufactured, you can export it and people are ready to take it. Of course, it is available in multi countries, but it is in a different mode, because of sometimes the as after 10 years or so, Nano was started manufacturing, and it was launched to market, and in a kind of very poor response. Though it's a great idea, Nano was great idea. Because of Nano, we have low cost cars like Maruti 800 and then Maruti Alto, and many low cost cars in India. So everybody is bound to launch a car which is low cost in India. But Nano, so Ratan Tata once told in interview that calling the car as 1 lakh rupee car was the greatest mistake, because then things happened in that way, and people expected that it will be below 1 lakh, but it has to be more than that for the right ROI. Okay, so that should be part of it. So facets, or what is the sequence to move in? First the study, then can we help those manufacturers to involve in some kind of engineering principles, or the principles like which we see across India, across factories, across world, like many industrial engineers make lots of gauges in factories, like go and not go gauges, fixers, and they are given us lots of productivity. Productivity gets extended by these industrial engineering concepts. I am sure even if you are not mechanical engineer, you know what is the meaning of productivity. So how to enhance the productivity? And enhancing productivity is one way. The industrial engineering helps us to enhance their productivity by two ways. One is by technological intervention, and second is by concepts. Concepts like, which are the industrial engineering concepts? Anybody? I want you to, anyone, industrial engineering concept which are enhance their productivity. Yeah, come in please, your chance. Chat here. Which are those? Industrial engineering concepts which are philosophical based, or industrial engineering concepts we call them. Everybody knows here. Have you heard the word like DQM, total quality management? Standardization, yes, very good. Standardization is one industrial engineering. So all kind of ISO, ISI, they are all standardization. Total quality management, TPM, total productivity management, and what else? Six Sigma. Kokayaki. Or there are so many industrial engineering concepts. If you have been to be in, this is a subject for any mechanical engineer these days, but I think anybody who is interested in any kind of fabrication will know these. Okay, industrial engineering concepts, they mostly traveled from Japan, and mostly they came from a company called A company
Kaizen.
called Toyota, TPS, Toyota Production System. So TPS gave us lots of industrial engineering systems, lean manufacturing, concurrent, Six Sigma, single meter exchange of dies. Those are the
Kaizen.
yeah, Kaizen. Yes, right, sir. So you don't say that I am from computer science, so I don't know, but it is everywhere. It is involved. Everywhere these product industrial concepts are giving us higher productivity, whatever we do. Okay, so can we involve those? And one of them is your dies, making fixtures, making gauges. So one famous gauge is, say, in my factory, see, if I am making, say, this pen, so I don't have to all the time go measure the diameter of the pen by micrometer or those. So what I'll do, I'll make some kind of quick gauges. So generally most of the gauges are called go and not go gauge. So I'll give it to operators who are simply ITI or so, and they will instantly see go means pass or not go means. So those gauges can help sometime. Okay, so likewise you'll see anywhere in the factories this kind of scenario. So that was the second part. Third one is assessment of the once this was done, can we assess the existing materials which are there in the contemporary material properties? Which are the material properties? Say mostly we call them mechanical properties. So what comes under mechanical properties? I think you cannot deny me. You must have studied a kind of Young's modulus, stress and graph. So if I take a simple ductile material like low carbon steel and I apply some kind of stress, so stress, that means load by area is stress, it will have some kind of strain inside. So this kind of graph is there which will tell me whether it is elastic or plastic region. So likewise, from where we get lots of properties, so those mechanical properties can be tested. Will anybody tell me what is that equipment which is used for this kind of testing? Which equipment is used? Anyone?
UTM. UTM. Sir.
UTM, Universal Testing Machine. That's the machine,
Yes.
and that is giving us all kind of properties. So there are so many other equipment also, but we try to identify those properties because from those property only you can move forward. Then of course another area is technological area is CAD CAM. So can you do computer design first and then do some kind of engineering? CAM is secondary. CAM, when we'll talk about additive manufacturing, we'll say CAM, or CNC machining, we will say CAM. But at least CAD and CIV is very important. We'll spend some time. So if you look at these words, even if you are not from mechanical engineering, you will be able to relate to them. So once you are done designing on computer CAD, the way you do for using cadence in your circuits, we do all kind of CAD software starting from AutoCAD to the advanced software like CATIA from Dassault Systems. Okay, and then for example, once you're done that, can you do some CAM, computer manufacturing? And once one of the CAM is additive manufacturing, that means manufacturing layer by layer, and this is nothing but you call it as 3D printing. So can we do some kind of 3D printing of Jaipur food? That was an idea. So this is the facets of manufacturing standardization we did. So we'll quickly move. So first thing, so look at the gentleman. He is like a cobbler sitting in a small workshop, is a 4x4 shop somewhere, trying to make Jaipur food. He will have a furnace. He will have some kind of cutting tools, and so so I don't have to explain each and everything here, but it was a need based. So important thing is I asked my students to visit them, observe it, empathize, talk to the operators, and find out what are their pain points. Once you find their pain points, you try to solve their problems. So whenever he's grinding or whenever he's, see, look at the product is made like this, and these are all people following no safety aspects and all those. So what kind of product you can expect from them? So if you use this kind of simple idea is they are doing cutting of this kind of rubber is being cut to make the blocks and all. So this may be a bigger size. It looks small in photograph. So you make some blocks out of it. So can you use this kind of templates? Say if you are making it for 9 size foot, can you use a simple template that this should pass like this? Okay. So similarly, while grinding also some kind of template can be used like this. So that are, see, if you are drilling some hole inside this wooden block, so can you not have a, so can you have a simple jig for while drilling, so that you don't end up drilling the hole misaligned. Okay, so likewise, if you have some kind of measuring tapes which can give you based on measurements, so that is tire cord measuring tapes and all those, so this will not only reduce my weight, this will standardize the product. So wrapping procedure was identified, we call it teardrop pattern. So those kind of fundamentals were involved. Okay, so once that was done, a set of stencils, I can call them stencils, they were all prototypes of the stencil, they were all 3D printed by FDM technology. If you want, I can discuss in detail. Or some later on, they were made by sheet metal. The sheet metal worked by aluminum sheet, so they were converted into different sizes. Say, for example, if you are making a foot size of 4, 5, 6, 7, 8, or 9, 10. So these are the manufacturing standardization which happened, and based on this, we asked them to, or we did not ask. I mean, they started using this, and we did a study on that. Say prototyping was tested. So earlier it was, say, this was the foot, and the mass was 900, average mass of the foot was 975 grams. While using this, it reduced to, see, it's a low hanging fruit, 897 grams. So there is a 100-gram weight reduction. You may say it's nothing, but ask somebody who has to wear it, right? So that matters. Similarly, these testings were done in terms of dorsiflexion, plantar flexion. This movement of the foot is dorsi and plantar. We'll talk later. The pronation, supination, heel compression, all those things were tested. Okay. Then once that was done, we try to educate those artisans which were locally, not in the bigger factory like BMVSS, but some local artisans which are manufacturing in Jaipur, local region, and we documented it and published to the people. Okay. The next thing was assessment. So what assessment was done for all those, the wood which are being used, or the skin color rubber or the tire cord, there all densities were measured, positions ratio were measured. Position ratio is another mechanical property. Young's modulus were tested, and tensile strength and compressive strength, all kind of parameters were tabulated. And this was done using our MRC, Material Research Center laboratory, where UTM is there. Okay. So this is, I'm quickly saying, this table of material which are important because they will be used later on. And then fourth part of it is CAD CAE. That means this is the foot which is in the artisan mode. Now, can I redesign it, and can I design it, use CAD for this? So that was the first step. Learning from this foot, empathizing with them, giving them something soft, and then trying to do some kind of modeling, design, and doing some kind of engineering, which we'll talk about. Then specifying the various parts and material properties, which I tell you from where we got from UTM in the previous table. And then identifying some kind of parts which can be standardized, right? And then, of course, lastly, additive manufacturing or 3D printing for developing those prototypes. And finally, the clinical trials, which may be still work in progress. So shall we move? So this was the fourth step. Sorry. Now, when you look at this CAD modeling, so those are the parts. Every part is modeled separate. That is the wood model. Everything is modeled using CAD software. Please do understand, this is not a rectangular or square or those kind of designs. No, they are all, such designs are known as organic designs. Organic. So it requires lots of CAD skills to get this kind of surfaces, the free-form surfaces. Another word for them is free-form surfaces. So it took us 6 months or so to do this modeling of this Jaipur foot. Once the model is ready, things are now easy. It can be given to anybody and they can relate it. So this modeling was done using CAD tool. Mostly we use the Autodesk tool called Fusion 360. And then within the software itself, CAD model was ready. The properties were added. So what are those properties? Those properties were what we took from this testing. So those properties were added. Once you add those properties during CAE, computer and engineering, that means it's very simple. Say for example, you have designed a cantilever. All of you understand cantilever. Say something like this, and now you apply some load. So it is behaving like a cantilever beam. Now what happens when you applied some load of say a small cantilever, some 5 kilonewton load? So what happens? This will deflect. So in spite of manufacturing the cantilever and actually doing the testing, what I'll do, I'll make a model of the cantilever. I'll do its engineering, CAE, structural engineering. Very simple idea. And I can, in the software itself, I can test that under these condition, under these boundary condition, this will deflect this much. So I can measure the deflection. Okay, I can change. I want to keep a deflection, say within say 4 mm deflection. So accordingly, I can say that this is my maximum limiting load. So those kind of engineering can be done. We generally refer it as CAE, computer aided engineering. Okay, civil mechanical engineers, they do extensively, but I think it is a tool which is to be known these days to any mechanical, any graduate engineer. It is easy to also understand these days with so many easy to learn softwares. Okay, so once you have those, once you have the data of this kind of complicated product like Jaipur food also, we could see that when you apply load, how the bending is taking place, where are the maximum stresses, red color shows maximum stresses, where is the displacement taking place. Likewise, we could do some kind of engineering and identify it. Okay, once that was done, so what you see here, maximum and minimum values of the stresses, strains, and the displacement in various parts of the foot was same. So skin mein kitna aaya, toe mein kitna. Likewise, we could see the various values of limiting values of various parameters. Okay, once more, we could do the next aspect. That means, can we do manufacturing of the foot by contemporary technologies? So contemporary technology, which is the most contemporary these days, say additive manufacturing. Additive manufacturing is also known as 3D printing. It is also known as RPT. It is known as RT. So I tell my BTech students that these are all the technologies which are not new. RP and RT is at least 60 years old technology. This got developed with the CAD/CAM technology only. But recently, after Obama initiative for additive manufacturing in 2008 only, we started calling them additive manufacturing. Additive का मतलब क्या हुआ? You add material, additive. अगर मैं मशीनिंग करूंगा लेथ में तो उसको क्या बोलूंगा? Anyone?
Subtractive.
So you can call all your manufacturing processes by 3 categories: additive, so subtractive, or say zero. So if you are doing some kind of foaming, you take some bulk of the load metal and you compress it. So are you doing additive or subtractive? So it is zero. So you can say all your manufacturing processes, either they are doing additive, which is a recent phenomena, or mostly all kind of machining, including grinding, finishing, they are all subtractive. You do A minus B here. And here this zero is those processes like clay modeling. You take some clay, school में teacher देते हैं बच्चों को, and they make हाथी घोड़ा out of it. So that is nothing but a forming process, right? So that is also a zero. So plus, minus, or zero. So these 3D printing have been started calling as, it is like a modern name of Amitabh Bachchan में फिल्म में शुरू में होगा बच्चों का नाम ऐसे चिंटू मिंटू ऐसे ही कुछ होगा, वो बच्चा दौड़ता आगे बढ़ के क्या बन जाएगा? मास्टर दीनानाथ चौहान, the younger name. So it may be the RT, rapid tooling, or RPT was the childhood name of this technology. Now these technologies are started calling as additive manufacturing. People also call it 3D printing, because 3D printing, because you 2D printing, I am writing is 2D. I am writing in X direction and Y direction. So this is 2D writing, 2D printing. When you print your name on the paper. Now, if I can get some third axis Z on it, so that is my 3D printing. So 3D printing concept came from a technology. So as I told yesterday, we have now ASTM technology classification. There are hundreds of additive manufacturing technologies, hundreds of 3D printing technology, but now we have a classification, and those classifications are referred as, we started calling them, as I told you yesterday, 7 families of additive manufacturing. You can just Google and find out. We call them 7 families. So the 3 families are only for polymers, only for plastic kind of material. Yesterday we said MVM. You can just remember material extrusion, wet photopolymerization, material jetting. So material extrusion is the most popular. What it is? Anybody will see 3D printer is material extrusion. That means this technology is known as FDM. So what you see, what you might have seen at a printer, mostly it is a 3D printer, which is FDM technology. So you have material extrusion, like toothpaste technology. You have a material which is extruded and melted from the tip, and as per the instruction from the way you do in printing, 2D printing, as per ASCII technology. Who will tell me the spelling of the ASCII? I think you know it. American Society for Characters Interchange, something like that. Anyone? Because many of you are from IT tech side. Who will say the full form of ASCII? I hope you know it. Because I have to tell my students how that, what could be the technology by which I write something on the keyboard and gets printed here, because every letter is like those 256 characters are modified. So those similarly, those ASCII letters are the ASCII characters or the ASCII information from this, as per this standard, goes and gets you printing in 3 days. So this is also an FDM printed. So this was polymer. So we went for the first category, first family group. There are metal printing also these days. So that comes under the category of, as I told you yesterday, MVM, BSPD. B is binder jetting. S is sheet lamination. P is powder photopolymerization. So those who are dealing in powder metallurgy, it's a great chance for them to move into this technology. BSPD. D is direct energy deposition, more like a welding. Okay. So we have gone for this 3D printing technology. So now we have printed it out of ABS, but it is not good. It is a non-functional product. What it is? It is a non-functional product. You can't use it as a foot. Why? Because it is a rigid one. It doesn't have any flexibility, and that's the purpose. It looks like only, but it is not a Jaipur foot. Why? Because it is not having the property of flexibility and all kind of thing. Non-functional, let me call it. So to make it functional, we wanted to go for some kind of equivalent material. So we went for this TPU, thermoplastic polyurethane. So this TPU was, again, as per the STM standard, it is a printable material. So those things were done, and it was tested for its properties. So we didn't get the properties. So again, you look at this STM. This is nothing but a UTM test setup. So under this, it was tested, and then it was compared, and various values were compared with, and finally it was printed. So what you see is this TPU 50 and 40 means its fill percentage. It was fill percent 50, 40. So with this, its weight is coming at 484 grams and 15 grams. So it was tested for static deformation under ISO 10328 for this moment called dorsey and plantar flexion. Okay. So I think you could relate to. This is the test happening in SDMS itself, but it is not fully done yet. Deformation is coming up to 5 mm. So if deformation beyond 5 mm is a failure. So this is the various deformation you see using TPU 40 and TPU 50. 40 is the fill percent 40 and 50 is the fill percent 50. So what is fill percent? Those who are not from conversion with the technology, that means during printing you can add what is the gap you want to keep. That is a fill percent. So if it is 100% solid, you can make it fill percent 100. It can be anything like 30, 40, 50 is fine. Okay, so that's what. So then again it was compared with the other material, and this is the additively manufactured foot with 40% fill percent. But let me tell you, this is the actual foot, and now we have an option that we can also think on its design based on these various materials. Moment the technology improves for additive manufacturing, it becomes low cost. This foot can be one day be functionally foot can be printed. Okay, but it's a work in progress, and clinical trials and all sort of stuffs are required to be done. So with this, we stop this case study, and I request you to ask me questions for anything related to this case study. Okay, before we move on to the next case studies. Any quick question? So thank you, Dr. Verma, for giving me the full form of ASCII, American Standard Code for Information Interchange. So that is one. So whatever you see, the transmission of data taking place is because of this standard possibly, and so many other standards which have come. Thank you. Any question from your side? So this is what we are supposed to now learn in next 1 hour 20 minutes or so, other 1 hour 10 minutes only, and we are supposed to interact and discuss about. But I am looking for any kind of interactive questions from you at this stage. No? All right, then let's move on, and you are welcome to ask me, chat me anytime. So let us see, because many of you are faculty members and scholars. So scholars and faculty members, as per AICT or whatever it is, the body we are governed with, what is the mandate that we should do some kind of research, because even our promotion, recruitment, everywhere this research world is troubling us, or it is for the past 20 years or so it has become a necessary evil for all of us, right? So let us understand the meaning of research. Is it the word meaning of creativity, and then this big word innovation? And what is innovation, what is invention, what is research, what we are doing in our lab, what you saw, you may say it was a good work, Jaipur food we did, you may say it was not so good work also, or we may talk about other developments. You saw yesterday about the pram bag, using, of course, empathy is very important, but beyond empathy it has to move in terms of research, so that we can, but this is the research enough, publication of paper is enough, what are the differences, what are TRL, technology readiness level? Let us see some 20 minutes discussion under this category. Okay, then we'll, which is for a condition called club food. Then we may study another spend another 20 minutes for this reverse engineering fundamental for a condition called drop food and a device called AFO. Okay, so you are all set? You are all with me? Rather,
Yes, sir.
say yes or no.
Yes,
At
sir.
least in the
Yes,
chat
sir.
box. Thank you.
Yes.
So
Yes.
yeah, for a question, please, if you have any.
Sir, what
quickly.
is the difference between fused deposition modeling and finite element method?
Oh, great, good question. So let me answer. So both are two different things, sir. Number one, you will say FDM. FDM is a technology of 3D printing, fused deposition modeling. It is model का मतलब यहाँ पे clay model या tangible model बनेगा. और FEM, finite element modeling, is a digital. So this is a technology called CAE. This is a technology for, it is CAM, and let computed manufacturing. That means when you make something tangible, one of the technology called FDM of 3D printing of additive manufacturing is FDM, fused deposition modeling, where you have a filament, you fuse it and deposit it on the surface so that you get your tangible product. Whereas finite element method is a technology which is, if you have, it is all software only, it is nothing tangible here. So when you have some CAD model, you want to test it for some kind of, as I told, gave an example of, say you have a cantilever, or
Yes, sir.
I think you understood the meaning of cantilever. So cantilever is here, which is a test. I want to test whether it is, I'll take a banana. Okay, I'll
Yes,
take this pen. I want to see whether it is failing or not in my hand. So what I'll do, I'll apply some load here. Now imagine this is failing because it's made out of banana. It is a banana in place of this. So it will shear off from here. In spite of having something tangible in my hand or having a test rig or applying some load, those are not easy things. So what we can do in the software itself. First we make a CAD model, and then we go for identifying the material of the particular product in CAD
Yes.
model, and then apply loads virtually. So that is, so for applying this, I have to convert this material into a finite small elements. They can be
Yes.
2D elements or 3D elements, that is finite element methods. Okay.
Yes, sir.
Thank
sir.
you. Thank you for interaction. Though the question may not be of that great, but important part is I feel that I am here talking to someone who is listening me. Thank you. Anyone else? So I think we can move forward. Great. So what do you see? What is a research? Anyone? Research? You all know, but I wanted to give you a systematic definition of research. And what is research for me? It is a systematic research is nothing but a systematic and planned investigation. Anything not randomly. It can be sometime out of a great idea. Those things are different. We'll talk about that. But a systemic and a planned investigation into and the study of materials and resources, and in order to establish some kind of facts or to reach to a new conclusion is nothing but research. The word meaning of research. Okay. So first we know the word meaning of research. Now how it is conducted, or what is the important critical element in research? How do we conduct planned investigation? So first we make some kind of hypothesis. We can make a explicit question sometime or make a hypothesis, and then we try to answer something कि इसका कारण ये हो सकता है, ये हो सकता है, ये हो सकता है, ये हो सकता है. So those are our implicit answers, and then to relate to the right answer we systematically approach and collect data. दो बार collect हो गया. Collect, approach to collect and analyze. One collect can be eliminated. Collect and analyze data or information to move from this explicit question to the implicit answer, so that we get a right conclusion. So that's the meaning of research. Okay, I know you are knowing it, but I thought let me initiate it because that's an important part. Now let us see, when you do research, what is the most important human resource which is needed for research? Or forget about research, I want to tell you, I want that you talk about, out of so many human traits like love, hatred, or acha or kharab, jo bhi hai, which is the most important human resource, particularly which you see is important for this world to survive or to grow or to blossom. I want your inputs here very quickly. Just be candid, answer anything which you thought. Just write here, please. I want to see at least 10 answers in the next 30 seconds. What is the most important human resource out of so many resources, like which you might be aware of? Jealousy, pain, okay, important. There are, but let us see most important. Okay, there are, okay, love, okay, feeling of brotherhood or honesty or ingenious, knowing about curiosity. There are human resources, there are human traits. Okay, out of this, which is the most important? And please do understand, we have a reference here, and the reference here is research. For the research reference, which is the most important one? Or we talked yesterday, design. For the design aspect, time. Okay. Okay. So I'll tell you a story here, small story. See, this is a reader's digest. Creation. Creation is close. Very good. Creation or creativity. Am I right, Dr. Masood? So a word has come, creativity. So creativity or creation, I think possibly is the biggest resource of humans. Or if you think there is no creativity, if people are not creative, what the world will look like? Or can you imagine it? Right? So there are so many thinkers, philosophers, they have talked, and they ultimately gave it a thought that the most important human resource is creativity. And there is no doubt that creativity is the most important human resource. And when I say creativity, it comes with lots of something known as, we generally refer as common sense. Creativity without the boundaries of common sense will be a foolishness, right? Sometimes it is good also, but it has to be, within certain boundary conditions. If you do some, that kind of creativity is worthy, right? So there is no doubt that creativity is the most important human resource of all. Without creativity, there would be no progress, and we would be forever repeating the same patterns in life. This is done by Edward Bono. This definition in quotes is written here. So if you are doing kind of research, whatever resource you have, we cannot complain about the resource. I can't say if I'll go to IIT, MIT, then only I'll be able to go for that. A good research, not possible, not necessary. I mean, at least with the world today so connected, we can definitely think that it is not a limit these days. The most important part is the creativity. And now, when we see creativity, I am bound to give you this, show you this slide, that most of the creativity comes from nature, because nature is the ultimate creator. Okay, so even if you look at so many human creations, say if you look at a creation like human creation like anesthesia, so from where the inspiration might have come from? Venoms, poisons. If you look at solar panel, from where the inspiration might have come? Leaf. If you look at computer, it could be from brain. If you look at computer program, it could be from the DNA of human DNA. If you look at microphone, it is no different from a eardrum. The inspiration has come from eardrum. If you look at a camera, it is nothing but an eye kind. If you look at an eyelid, it will give an inspiration for a windshield wiper. If you look at a wiper fluid, it might come from your tears. Look at the nature, its creation, which are existing for I don't know how many years, but they have motivated, they have inspired people to come out with this kind of. If you look at, say, knife, it might have come from my teeth, the insider teeth. You look at a pump, it might be nowhere different from a heart. So likewise, communication. So music, the song of the birds, poem and all. So likewise, that is what is, the inspiration is fine, but that is what is creativity. So I am bound to give you these definitions of creativity. The creativity is the ability or a quality displayed when solving unsolved problems. So if you look at this, if you fundamentally relate to, so then you can come out. So, but what are the components which are needed? Domain relevant skills. If you are thinking, if I think that I'll do some creativity in surgery, can I do it? Because I don't have the domain related skill. Then within the domain related skill, that means I must be having reasonable knowledge about it, reasonable skill about it, and then I must be creative enough, following some creative process, and I must be motivated enough. So these are the three components for any kind of creativity to be successful. So what are the stages? It could be like preparing, then and at least once you have an idea, it could be preparing that and doing the basic thing, then incubating it, then further thinking inside, day and night, evaluating, elaborating, all kind of stages will be there. Otherwise, what is creativity? Which is which is like solving the points of pain, the pain points of the society or the individuals. For that, you do all kind of creativity. So in this context, we could mean that new processes or products, or new ways of using existing products, or new services, everything has come from a creative thinking or creativity. Okay, so that is one important part. Now please do understand, we should not forget while doing any kind of research in our institute, or as a scholar, or as a PhD scholar, or as a supervisor also. Now there could be a question, you can say creative people are born, so can everybody needs job, everybody has done MTech or done PhD, and now many have done PhD and they need job, they want to be faculty, but do you think they will be good researcher? So there is a school of thought. One school of thought is creators are, do you just tell me what are your inputs with respect to whether this is a illicit view, that means they are born, or they can be made. So how many of you say they are born? Creativity cannot be incorporated. Say yes. Creative people are only born. They cannot be made. Anyone or everyone? You should please put your question. Say yes. That means they are only born. Or let me frame my question likewise. Can you make people creative? Can you make people creative? Can people be trained to be creative? Can people be made to be creative? Can
Yes.
people be made to be creative? Yes, very good. So lots of yes. So there may be 19-20 का difference हो सकता है, but yes, can. So there are two views. Let us work on those two views based on looking at the time. So the literature suggests that creativity can be innate. That means what I am trying to write here is not from my thought only. I referred some kind of psychological books and all. So it is innate means you are born with that, but it can also be learned. So you can be better over a period of time with practice. So this is development view, and this is the first one is ELICE view. So getting new and valuable ideas, a rare talent. Of course, why it was only Newton who discovered gravity when the apple fell on him. But other than that, available to everyone. It is available to everyone, and it is evident from personal modest insight. One can be creative. Okay, so those, if right kind of encouragement is given to your scholars, to your students, or right kind of ambience is produced for the climate, it is written here. So it can be released. Creativity can be released by training and development of personal, and they can be of right potential. So it is not that people in USA are the most creative. We are not. We can be equally. Only difference lies in the ambience and the right thought process and right kind of training. Okay. So any comment from your side? I don't think any chat is there. So creativity is a personal problem solving process of non-routine kind. So if you are saying so something like that, out of box. So it is as simple as that. Say it is not that, say there was a school, in a typical school in a village, and उस school पे से tap लगी हुई थी. So 5 tap लगी हुए हैं. In the recession, kids will come and they will have water from this. But schools are there from say LKG to say 5th standard. So the height of the kids vary from say 3 feet to say 5 feet. Now, if it is all the taps are put at 4 feet, is it convenient for everybody to have comfortably have the water? Possibly no. So what somebody has just given, a school girl only gave an idea that in spite of having the all taps parallel, why don't you just put in a different, all एक ये जो length है इसको आपको सीधा parallel करने के बजाय जमीन के, you can just have it like this. So this can be at 2 feet height and this can be at 5 feet height. So those taps can be like this. So a simple thought which need not to be, but only thing, when you empathize, when you see people, you can just see, you can be creative and solving the problem. Okay, that's what is. So solving the problems in a non-routine way, not in a monotonical way. Okay, so it is like this way. If you face a problem, this cartoon I took from net only. So if you face a problem, you end up crying here. But if you face a problem, there could be some lateral kind of thinking. So that lateral thinking can give me a kind of solution which may be sometimes better than the solution which is there already. So these are all thought processes we talked about. Now from here, very important thing, because India has lots of paper publication these days, lots of research is going on, paper is published, but is it worthy? What is the right need, solution, or the right kind of, say, if in terms of product we talked about, we should be able to see that can we solve our society's problem, and that is only possible that even if you look at, say, I don't know why, but I can tell you an example. Now things have changed, but I happened to visit to Kanpur in 1994, and I knew IIT Kanpur, such a great institute. But moment I get down from station, I was to go to Chakeri, Air Force Station Chakeri, and I jailed there. In 1994, I found such a filthy city. The first thing it came to my mind is such a great institute like IIT Kanpur is here, and such a poor, pathetic city it is. That means what? Is IIT Kanpur responsible for the municipal part of it? But no, some problems can be definitely should have been solved. So now things are now within. I think we all understand that cleanliness, hygiene, lots of institutions are involved. Even your campus can be involved within the local problems you see all around. So those are the change in culture, change in mindset which is happening. Okay, so we were into this paper publication. So if you look literature, you will find that whenever we do research, any idea you have, say you develop something, you make a good circuit, simulate it. So the idea stage is technology of, we call it technology readiness level. That is idea 0. Now, if you find based on this idea only there is some product, it is commercially viable, commercially it is successful, it is technology readiness level 10. Please do understand it is this TRL between 0 to 10 only that is important. What you see here, if you have done some kind of setup, done some kind of experimentation, you have enhanced this TRL. By TRL 2 or so, you make a small prototype, maybe a very, very poor looking prototype, but you have made a prototype, you have done some experimentation, you have even published a paper. So that is TRL 3. But actually, the commercialization requires you to have at least TRL 10, 9 or 10. So what are those things? This is known as valley of death. And this is not my word, but Professor B. Ravi's word, which he frequently says of IIT Mumbai. So if we have to just identify one product and do, instead of doing 100 things together, if we can do this and then try to bridge this valley of death, can we move to this level? That will be referred as innovation. So if I do some kind of research, if I have done some kind of good experimentation, even I have filed a patent also, that is nothing but an invention. But it is not worthy until unless you convert it into TRL 10. TRL 10. And TRL 10 is done by innovation. So every unique thing is an invention or a research. Research is that process. But if you can move into its TRL 10 level or the commercial viability level, you call it an innovation. Is it clear? So now we know these words, we'll be able to relate it. So there are newness or adding value. If you are adding value functionally, it is called technology based. If you are adding value, symbolic value, it is called design driven. Okay, so it is, as I told you, industrial designer. So this is form, and this is function. But do not forget the humans. So human approach is, if you're done, that is your design thinking, or particularly empathy. So the degree of newness can come. Say, look at any product. It can come incrementally. So you can have incremental innovation. Every 5 years, you have some 5 features added, new features added, and you find that modern day. Say, for example, cars. In last 200 years, they have grown, right? But has there been an appreciable change in the design of the car or the product? Possibly no. There is no hardly any radical innovation. You understand this? So tell me an example of incremental innovation first. I just need your quick inputs before we move on to the next step. Any example of incremental innovation?
Mobile phone, sir.
Mobile phone or telephone? The way we communicate,
telephone.
is it? Huh? The way
Telephone,
we communicate, Telephone is incremental innovation.
Yes, sir.
Okay. Please write. Let us see which are those incremental innovations, or rather, let us see which are those radical innovations. Radical innovation means more than 20-30% suddenly valuation will change हो जाएगा 20-30 times, not percent. Something which is there the way you are doing right now, but there is a disruption happening, or radically you have innovated everything. Say for the past 70 years since independence or so, we were doing banking, right? We had banks. Am I right? Has anything radically happened in last 5 years?
Yes, sir. That is internet banking.
So not only internet banking. So who is responsible? So I was just going through a Vijay Sharma interview from Vijay Sharma. He was talking with, I think, Pranav Roy or somebody. So Vijay Sharma was saying, who is Vijay Sharma? All of you know Paytm.
Yes, sir.
So Vijay Sharma of this Paytm founder, he was saying that all the technologies, there had been lots of efforts since maybe 30-40 years for this net banking based on these apps and all. But it was only in recent times when the technology was there, this COVID came and those things, the net banking, and then this the banking sites, and maybe this. So we were doing all kind of buying and selling. Markets were there for the thousands of years. But what has changed? The disruption or the radical innovation in markets have taken place when we have what? This commercial, or we can call it IT, has come, and the way the things have disrupted with Amazon and Flipkart and all those. So those things are, so let us understand this radical innovation. So before I want you to talk about it, these are all radical innovations. So the letter which was, the communication which was happening like this, email came, and now this, they are all radical, disruptive innovation. The telephone which was there, it took lots of time for the gram bell, but the way it has radicalized one stage, and then moment the smartphone came, the rest radical innovation. So those are just for the sake of innovation I am talking to. There can be two driving force for innovation. One can be technology, say for example technological push. What you see here, say mobile phones and consumer goods, they are all because the technology is there, they create demand and they push the market. So this is a push type. On the other hand, say for example vaccine development, it's a pull. This is a market pull. Market is demanding the vaccine. So there is an existing demand. Suddenly we all have to have vaccine. So you quickly develop the technology, RNA, GNA, RNA, or whatever kind of those vaccine-based developments have happened in recent times, and then you give it to market. So this is a pull type. So those are two scenarios whereby you get innovation. So push type and pull type. Okay. So these are the two scenarios. But please do understand, it matters when you have radical innovation, but this is also very important. In aviation industry, most of the innovation has taken incremental. So whenever there is an accident happening, it went very well, very well researched and then studied, and then improvements taken place over a period of time. With even you are in airborne, but aviation is still the safest mode of transportation. You should know that aviation is the safest mode, because it has incrementally innovated. So everything is important. Incremental innovations are very important, and we generally, if we have this small delta improvement also, those things are not bad. Okay, so this is what we talked about. We moved from research to innovation, and look at this, jumping to the next curve. What do you see here? A simple idea. Say, maybe imagine the case when you have ice requirement. So whenever there is a winter, or when there is a snowfall, you will collect and do harvesting of ice, maybe 500 years back. Then came these ice factories in our own time. When we were kids, like we will get a slab during some marriages and all. and the slab will be kept, and we'll be very fond of having those cold drinks, locally made cold drinks. Okay, and then it in the last 20 years or rather 30 years, this refrigerator, every house will have a altogether different scenario of. So you can relate ICE 1, 102, 100, 200, 300. Transportation. So this was maybe one transportation 100 where incrementally it moved from horses to cars. But suddenly the big disruption is happening in terms of these app-based taxis and all. So transport 2.0 may be changing this up. So please do understand these are all fundamental things. So which you have talked about. Now we can definitely move on to these three words and linearly we can relate it. So what is research? A problem solving process of a non-routine kind, whereby you need a kind of creativity. So please do understand, tell your students, or if you yourself is a scholar, if you want to publish a paper or anything you want that it is appreciated, you have to have some kind of creativity within that, out of routine, non-routine thing. So carry out, involve this research and creativity together. Otherwise, it is not. Is generation of, so research is routine. Research also is possible. Somebody did these 10 parameters they took and they did some kind of experimentation and found some responses and tested it, validated it, made a mathematical model, published a paper. That's a research. But if you generate suddenly some inventive step which is, so whenever we say something is patentable, three things are required. One is inventive step. It is a novelty. Let me write the word novelty. Then second word is, it should be non-obvious. Sometime non-obvious. So if you just look at India's patent office site, you will find these three things. Anything can be patented if it is novel, if it is non-obvious, it has some industrial application. So that is nothing but an invention. But invention itself is not sufficient. It may be in the TRL 3 level maximum, 3. So this can be patented. But this is nothing, I tell you. Ultimately, you have to go for this bridging the gap at design and development you carry out. Use this research output, these patented inventions to develop a kind of, say, if you can think of a kind of a business kind, if your students can do that kind of a improved product or a process, then only you will refer it as, can commercially exploit it, that will be referred as an innovation. So these are 4 words I usually thought that should be identified here, and they should be related to design thinking also. So you please do not, we need design thinking definitely at the early stage here, but every part of it. So we again come back to the same stage, our Dukkha Nirvana stage. Okay, empathize, analyze, solve, and test. Now we can talk about this famous bridge, and this I have taken from Professor B. Ravi. May not be precisely, it was there on net. So these are all research and inventions in the one side. All academicians are doing this. But ultimately, you need this TRL 10. Innovation and new businesses are the required. In between is this valley of death. You can call it Darwinian C. The struggle of inventions is to become innovation, is this. So if this is the difference, many people ask, even what is the difference between invention and innovation? I think now we can relate it to. So if you can have some kind of CD, some kind of arrangements here, those are nothing but, क्या कहेंगे इनको, वो arrangement क्या कहेंगे? Anybody? What you will call it? That ecosystem, what you will call it?
Invention.
What you will call it? The ecosystem for bridging this gap. Inventions are here, sir. They are here. They are here. You are identified, given a thought, or even published a paper, filed a patent. We are doing all this in the universities, colleges. But this is not
Incubation,
sufficient. Ultimately, innovation is new businesses. But ये खाई कैसे पाटेंगे? ये सवाल है. खाई पाटना समझते हैं?
yes sir. Commercialize करना viable.
This is valley of death. So how this happens? How this struggle of these inventions to become innovation is important. So please, even if you are not paying attention, now I want you to pay attention. This is the crux of it. So if you think that whatever you have done, whatever research you have done, until unless it is commercially viable, it is worthless. This is what everybody says. So it is worthless. Sometimes we do worthless research also, not a problem. But if we have to genuinely think, you passionately think that whatever invention or research you have done is a worthy thing, you have to cross over this. And cross over this के लिए जो support system है, they can be referred as incubation centers. Incubation. You understand incubation? All of you understand incubation? Incubation, incubators, जहाँ newborn baby को रखा जाता है, वो भी incubator होता है.
Yes sir.
So those ecosystems, those arrangements, those vyavastha will be referred as incubations, or those cultures. So these days we have lots of they will call them innovation and incubation center. That means you have your research and innovation ready with you. If you don't have, please don't go open that door of innovation, these incubation centers. If you have something here, if you think your idea is great, you should try to cross out this bridge. And these days government is helping. Lots of innovation centers have come up, lots of incubation centers have come up, and they will help you to cross over this. Okay, so that is what is the essence of it. And of course इसके लिए जो system जिसके लिए बोलते हैं IE ecosystem. What is IE ecosystem? Innovation and entrepreneurship ecosystem. So if you have if you could innovate it to the level of TRL 10, well, you can be an entrepreneur. It's totally up to you whether you want to transfer the technology and get money and enjoy your life separately. But if you yourself want to carry it forward the business, which many people do, this is known as entrepreneurship. So with this slide, we have covered so many things. I hope you will be. So struggle for life in a sea of technical and entrepreneurship is written here. This is the struggle. Okay. So with this, we stop here as far as these primary things are concerned, and we move forward to the next case study. And this involves extensive use of design thinking. So we were here. Any question up to now in this case? Okay. So in that case, we can move on to these two case studies, which I will be little faster. And I want you to now move on to the next thought process. We talked about something known as prosthesis. So prosthesis are what? Those artificial limbs. But it is not that people need only artificial limbs sometimes. They sometimes need orthosis. Or what are orthosis? And together they are known as P&O, prosthesis and orthosis. This is one branch of paramedico. Of course, specialists of doctors are there, but even paramedical, if you look at, there is a branch of paramedicos which is known as P&O, prosthesis and orthosis, which are helping these days, and with lifestyle disease and lots of problems, health related issues in times to come, this is going to be in a big way. So what are the orthosis? Anybody? Those supporting element. Yesterday somebody came with the idea, what is polio caliper? If somebody has a problem like polio, what is that polio? Calipers are, or supporting elements are prosthesis. Prosthesis, orthosis. Even what is your chashma? What is this? Is it a prosthesis and orthosis? Anyone? Just write P or O. So one thing is very important. We should come out of it this the philosophy of this Divyang or physically handicapped and those people, because this is nothing like 70% of the people, those who wear chashma, they are also Divyang. So we have to come out of this thought process that oh ye to bichara hai, ye hai wo. No, that is not a thought process. We have to empathize. That means whenever you go for specs these days, by lens card and all, people are ready with their this has become a fashion statement. So tomorrow maybe future people will be they removing their limb and then come out with a designer limb. So that also become a fashion statement sometimes. So the whole idea is the whole stuff is we are looking for these things are called orthosis. So there could be 2 case studies quickly. So we'll talk about lower limb orthotics very quickly. You just look at, if you look at a human skeleton or even a leg, just look at, you need to support something, your ankle foot, or sometime your knees, sometime your the bones in terms of the back problems and all. Sometimes the wrist support you need. They are all nothing but orthosis. If there is an orthosis which supports your ankle, you call it AFO, ankle foot orthosis. If it is an orthosis which supports this portion, your back problem, you can call it TLSO. So what is this reason is known as? Anybody? Are you aware of this term called lumboscarsal? So they are all lumbar. Lumbar means the spinal cord, which we call L1, L3, L4, and then S1, S2 or all those. So L3, L4 is a very common common L3, L4 is a common site where we have the back pain. So they are all orthosis. Okay. Once you understand the orthosis, let us understand this condition. Why we need to work? Why Indians have to solve this problem of India? Because this orthosis requirements are unique. It is endemic, not pandemic. It is not that every world faces the same problem. No, it may be unique to the community, unique to the society. So what is the idea here? They are all endemic. Or innovations has to come from within that region. Otherwise, who will solve the problem? No one will solve. Others will not come because this may not be commercially viable for them. Okay. The whole idea is we should be looking for some kind of indigenous innovations, and we understand that, say for example, even if you look at lower limb, what is lower limb orthotics? Because walking is nothing but, what is the biomedical term for walking? Bipedalism. Bipedalism. This is the most complex activity of human body. You walk, thanks to God or your luck, you have a wonderful health. Otherwise, look at those people who suffer because of walking. And it is not that they don't have legs; they have, but they, because of some reason, because of old age. So look at this data. 7 lakh 5.4 million are suffering from this movement-related disability. Half a crore people are suffering from this, or they need some kind of assistive device. It's only for walking. Forget about back pain. Forget about wrist and all. So assistive devices are available in market, but they are all skill intensive. They are not customized to local people. They need highly experienced medical practitioners. They need time intensive, and they are not low cost. May not be suitable for society. So that's what I am trying to say. That even if you take one domain, there is a huge scope for us to do kind of work. So we thought this work. When I was doing some problem solving on Jaipur food, I interacted with lots of doctors, and we came out with a problem called CTEV. If you have heard or not, this is known as club foot. Some kids are born with a twisted legs. This is congenital, means by birth. So what we did for that? So if you want to quickly learn, otherwise you can now onwards you will be knowing in case you are not heard. C is congenital, T is talipes, which this is known as talipes region, and equinus is horse-like. See, this is an equinus condition, or varus is inward. So this is an varus condition. So biological name for this disease of club foot is known as CTEV. So even if you look at this CTEV. Say what you saw here is a CTEV patient. What you saw here is a CTEV patient. Okay, and there are 1 out of 800 babies are born with CTEV problem. So how the solution is taking place? I'll tell you quickly. This is done by this gentleman, wonderful man. He understood the biomechanics of it, a foot, and he came out with a non-surgical method. We call it non-invasive method. And he is Dr. Ponseti, so his method is known as Ponseti method. What he does, he first the baby will come, even a newborn baby, he will give some kind of plastering. That means some kind the practitioner doctor will be doing some kind of manipulation. This happens for at least 6-7 weeks, and then once this is done, of course, surgical only for 5%. So we are not looking for surgical. This is not in our hand. But once this is done, it goes for a kind of bilateral brace for that patient. And this treatment takes 2 to 3 years. First stage is known as correction. Second stage is known as maintenance. So if you have seen it, a newborn baby, imagine a condition, a baby who has been newborn, lots of happiness in the family, and next day itself you come to know that the baby is suffering from this CTE problem, this kind of problem. And the treatment is long treatment. And one has to wear the bilateral brace. So we thought there is an opportunity, and sometimes this is a 50-year-old process again. Lots of problems like this, skill dehydration and those things will happen. Everything has to be done by the doctor itself. Paramedicals cannot mostly do help here because they won't be able to understand the manipulation. So the idea is, can we help? So, and that helping was, we'll talk about it, that we can get rid of these two things, repetitive cast for correction and this splint for maintenance. So we moved on and look at this. This is the maintenance phase. So imagine your baby for around 23 hours per day for at least 9 months, 6 to 9 months, wears this kind of brace. And you have to take your baby across buses. And now imagine if you are so good, having lots of time in a family, you get this kind of treatment, fine. Otherwise, imagine a case where the parents are poor, they are not able to take care, and this will end up doing what? Leaving the treatment in between. So that will give you a permanent disability, what you have seen in the beginning. So can technology help? Can this thing can be treated by some better ways? Whatever technology we are studying, can it be useful? So if you look at, this is the technical word outline of this Ponseti method. I have tried to list it. Kurtzi Samsir, who has published a review paper, Clubfoot Review and Assessment, Treatment and Challenges and Use of Engineering Aspects. So this will be published soon. It has been accepted. Now, this is, the terms are there: supination, adduction is done, then abduction is done, then this sternotomy is carried out, then this orthosis is used, FAB, bilateral orthosis. This is FAB. And then only you have to wear it for 2-3 years, and then only you can get this treatment done. So this is the algorithm of Dr. Ponseti. It is the golden standard for the CTE treatment. 90% of the patients who have been corrected are done by this process only. It's a non-invasive method. You hardly have to do any kind of surgery except this small treatment. Okay, so this is the Ponseti's method. If you look at the skeleton of clubfoot, I just want you to appreciate that the bones become like this. So for doing this, treating this, we wanted to do a kind of what? Empathy study, our golden process. So who will do? A newborn baby will not respond to you that this is good or bad. So we wanted to talk to the users. And who are those users? End users or those stakeholders? Doctors, parents, right? So empathy study was carried out. So this study was carried out from doctors across the world. A survey was hosted by some say to some. Of course, this work is being done for the past 2017, but he joined very recently, a year back. So what he has done is this survey was carried out to various people, 500 plus clinicians who are doing treatment across the world, whether they would like to use some kind of technology for treating this. So 48% say yes, 15% say strongly yes. That means there is a scope that this treatment method should be involving some more kind of technology. And see, across countries, 25% from India, 22% USA, Bangladesh, and all European countries, even they publish this survey in their global chat box, global birth defects, that publish a paper titled this study. And it was in it is not published, it is communicated to them, so possibly they will accept it. Then another study was commissioned for parents, and this we call again empathy study or journey mapping. When you study empathy study, yesterday I was asked that I should give you a literature for design thinking, and there is a huge literature available, but I will give you some PDF developed by me. And meantime, you just Google it up, and there are X number of books there for design this design thinking. And one of the term you will come to know is journey mapping, particularly empathy study. So look at, we did a journey mapping to these parents of these 75% patients who have been treated in SDMH in last 2.5 years. And now what we found, we identified some kind of map, and then this map says during travel, with the surgeon, with the paramedical staff, there are two types of doctors here involved. One is orthopedic surgeon, second is PMR, this physical medicine and rehabilitation specialist. So there are paramedical staff involved, there are P&O staff available. So they are in one set, and they are in one set. PMR and P&O work together. Okay, and then at home also. So what are those questions we asked, designed this survey? What are the happy moments? What are the pain points? As I talked in the beginning. So during travel, if the baby has to come from Badme to Jaipur, say by bus or train, what is they come to know about the social difficult to handle in public transport. And you know, there are social stigmas. People will say, "बच्चे के पाँव टेढ़े हैं, पता नहीं ये तो क्या पैदा हो गया, भूत पैदा हो गया." This kind of thing will come. It is part of the society. Then when they talk to the doctors, the treatment duration or extensive visits are required. Then what are the opportunities? We'll talk later. So during the paramedicals, the baby will keep crying. PMR, what are the pain points during PMR? What are the pain points during P&O? What are the pain points at home? And what are the opportunities? Once you do this journey mapping, you will find, can we do something by which this journey can be avoided? Travel can be avoided. Can we do something by which the visits can be avoided, minimized? Can we do something by which this cost can be limited or avoided? Can we do something by that, in place of, sometimes the baby will have problem in one leg only, but you have to give the brace which is a bilateral. So can we reduce the bilateral? So unilateral brace is like you're wearing shoes, but bilateral brace is like a, they say, when you have some, you must have seen some cattle, उनके आगे के दोनों को टांग को आपस में बांध देते हैं so that they don't run away. So that kind of brace is bilateral brace. So again, when you talk about P&O level, the fitment of this brace is a challenge. So can we do something for with the better fitment? So these are all journey mapping thing. And once we do that, it is not only that journey mapping part, but we'll have to also see that we have to reduce and do again empathy study for the students. If you talk to a student and if you talk to the medical term, metatarsal, cuboid, this thing, that thing, he'll run away. Once MTech student has left me and gone to some other faculty. Sir, what are you talking? I am a mechanical engineer. You talk this dorsiflex this thing. No. So what we did is, I talked to the PhD scholar that you don't run away. I'll give you a simpler term. So, you know, if I have to took in terms of aviation, we have three terms. One is pitching, yawing, and rolling. Three terms, three motions with respect to an aircraft. So very similarly, with respect to this movement of foot, so we found some planes. So doctors, they call it sagittal plane. So this is the plane, cross-section plane. In this plane, there are two motions. Similarly, there is another plane called transverse plane and frontal plane, what we do in our engineering drawing. So this plane, YZ, XY, and XZ. With respect to these three planes, I just simply just related these motions like eversion. If you move it eversion, look from front, it is like rolling clockwise is eversion, rolling anti-clockwise is inversion. So doctors will always talk to in their terms, but we will have to understand in our own term. If you look at, say, simply foot comes down and so pitching down is nothing but your plantar flexion. Pitching up is nothing but your dorsiflexion. So those terms are identified quickly. I'm trying to let you. Then there are so many deformities. Even those who want to join military, the flat foot is another area where this is known as cavus. This cavus problem. This is a normal foot. This is a flat foot. So the cavus angle, and there are lots of things which one can understand, and we could also relate it to and publish it. Then we found this deformity angle. So I am just moving, but please do understand, before I moved on to this, in 2017, I developed a problem statement and gave it to my BTech students. Can we design and develop a non-invasive device for treating this kind of patients with multiple and simultaneous correction motion, so that this problem can be avoided? So based on this statement, we moved to lots of steps, identified things, and with all kind of free body diagram, identified the joints, terms, the clamping, doing kind of biomechanics, and then just look at a kind of first CAD model, which is 2020 January. So our whole idea is we will have an orthosis which will be more humanoid, more baby-like. It's a unilateral, एक पाँव में पहनाना है. This will have a kind of motions, so that not me, not you, but only doctor will prepare a sheet and give it to the locally available paramedicos or his informed parents or his informed parents, so that every week, as per the doctor, correction, so that this kind of travel and those things can be avoided. Not only this, the hypothesis will say so many things. We will make it IoT based, we will make it smart, we will make it actuators, sensors will be there. All those things we have incorporated. But first thing is that the mechanical aspect. So first these are the May 2020 design I am trying to show you. So we are calling it as remedial orthosis for correction and maintenance. Then if you have to make this kind of orthosis, manufacture it is pretty difficult, even if you do 3D printing. So this was the 3D printing in ABS, which is looking not that good. So we have to go for a newborn baby. So this is a small, and this is MNIT, this is known as MVP, minimum viable prototype. This doesn't have any kind of locking or locking mechanism. So the first, it looks like something is orthosis. And then we are in constant touch with the doctors, Dr. Anil Jain, Dr. Kapil, Dr. Joshi, and then of course they give the feedback and we try to incorporate it. Another aspect is what are the different sizes, because babies don't grow they grow very fast and they grow in a multi-direction. So we did this another study for sizing purpose. So this time we took some 550 children, not having CTV, but healthy children in the age group of 0 to 2 in the hospital called JK Loan in Jaipur. So what was the purpose? We prepared some industrial engineering concept like this. We measurement, and we wanted to know from an age group of 0, say 1 week baby to 24-week baby, how they grow, what are their sizes the foot grows. Say in case I look at the sizes, I can understand that these are the measurements. Say what is this height, knee height, or this L to L length will be there, foot width will be there. So identified these parameters: foot length, foot width, heel width, thigh length, and then for different age, 1 to 8 weeks, what are their sizes. From there, their sizes, how many patients were there, 500 plus. So we wanted to do for early stage. Why? Because doctor told us that treatment has to start early. So we did this, and based on this, we identified some kind of change in the length. Based on this change in length, we will come to all parts of ours. So you look at those parts, those components. Every component will have lots of components. So based on this component, this measurement, we identified those components, gave some name to it, metatarsal, top, bottom, ear link, this thing, that thing, and identify at least 5 configurations, because configuration means you cannot fit one kind of orthosis to from 0 size to 2-year baby. So what will be the sizing? What will be the manufacturing process? Those things were identified. So this is what the 5 sizes. We went for modular design. All those things are there, and it is a work in progress. Again, I tell you, and how this work is possible. It started from a very small, recent starting. When I gave a BTech major project to the BTech students, initially we went for only 3 axes. So this group of students from 14 to 18 who graduated in 18. Then this group who graduated in 19, who graduated in 20, 21, and now 22. They have just graduated. Now this will be available. So 4 groups have already graduated, doing their major project of this work itself. So that if you just look for those consistency, I don't mind showing their photographs, and these are all young bright people. They are already working in lots of industries. If they have some time, I invite them to come and work on this particular problem. But they are very passionate people, and this is how ordinary people, ordinary faculty, ordinary students doing their major project and coming out with some kind of solution. Okay, so that's what is your CTV based case study we talked about. So I don't have much time, so I'll also talk about another AFO based study. This is what a word called gait. Gait is nothing but a walking style is gait. So even if you look at walking style, the old age problem, which all will be old one day, will be many of them have this problem called drop foot. So for this also we went for a studying something, how this ankle foot orthosis is made. So the idea is we wanted to study how this is made. So if a patient goes to a doctor on day 1, he will see that, oh, you need a measurement, or you need an orthosis like this. So the idea is it takes around 10 days. First they will take a measurement, then they make this kind of positive mold is made, then they make some kind of this, improve the mold. Then it's all artisan based. Please do understand, it's all skill based, and humans do mistakes while doing this kind of work. Then they shape it, put this kind of polypropylene sheets around it, they cut across, and then they put these buttons and all. It looks to me a very vintage kind of process. So I thought, why can't we have some kind of modern process? And it is not that we thought, it is there in literature, people have done already. There are some established protocols for this, but we can't afford it. Why? Because 20 years back it was not affordable, but now things are affordable. Why? Because lots of so low cost open source softwares have come, low cost printers have come, low cost scanners have come. So I told my BTech students, this is done by MTech Scholar, to develop a contemporary flow for fabricating an AFO using contemporary technology to shorter the life cycle and more comfortable for the stakeholders. Okay, so I'll just quickly take you to this. So first idea is to scan the foot. जब भी कोई patient पहुंचेगा, just scan the foot using a 3D white light scanner, which is safe for the human beings. It's like light only. Then generate some kind of cloud data points. They will be there in the software. Then you process it using some kind of software. So Autodesk Mesh, which we used. Then you develop a orthosis out of it in a CAD model. You do any kind of CAE, as I told, for shape optimization and all. And finally, you convert some CAM files like STL and print it. So if you do this, you can take the measurement here with a doctor and send this data to somebody sitting with me, say in my lab, or any engineering students sitting anywhere. This can be done in 3 hours, and then can be printed for same can be sent to the doctor. He may or she may have a printer, So this can be printed and given fitted to the patient, which will be highly customized by it. Otherwise, it's a very, very difficult. So I'll quickly take you to the class scale, all kind of CAE done. This is the flow. So even if I tell you a simple model foot, so this is the scan data model. From here, I can take my data into my computer and do the post processing. I can extend, rotate, and then based on this, I can carve out my orthosis in computer itself. So this is carved out from the shape of the patient, and then I know my material for this. Say if I have ABS or polypropylene, I can submit the data for this and do a kind of CAE, computer engineering. Now you know that where the material is extra, where the material is needed, so I can remove extra material in the CAD model. Then I will convert into CAM file. CAM file is computer manufacturing. You know, in additive manufacturing, we call it STL files. In 3D, in CNC machine, we call it NC files, .NC files. But since I am doing 3D printing, I can print it and give it to the patient. So that becomes the final workflow. So that comment here is it is possible to work on this. So these are masters and PhD scholars who have worked, including students from Ohio State and Colorado State who have worked on this particular project. Right now, Samsher is working, Smith Kumar is working, Praveen has graduated last year, Sivender, Priyanshu and Aniket have also graduated, and they are also graduated biomedical students who came and worked in my lab for 10 weeks for 3-4 years. So they have moved on. So this is what I think we are close to our time. But before I say bye and over to you for questioning, I want you to appreciate that these UG students, they are more passionately involved through this CAM society. Here is I have a club in my lab. We call it CAM society, and it supports lots of students and lots of industry supports it. And these are the students who run it. Lots of achievements are there. Lots of events can be created, and of course, even I submit my write-up notes here also. Anything related to advanced manufacturing, additive manufacturing, nothing biomedical here, of course, but electronics related, mechatronics related, whichever I know, I'll try to put it for the and automation related, so that they can be used by the students. So I also acknowledge these grants from various funded research agencies. See, the first grant which was very useful to us is which was fantastically used by this lab development was from the NSF USA, and then we got some money from Orthotics in a small way. But last grant which we got recently in August, which we started working last year, is this from DBT BIRAC, from DBT, which is a company from DBT, and we want to develop this orthosis for CTV. So this is the remedial orthosis for CTV project. This is another project from DRDO for composite material. Another group of students are working on it, and this is another group from DS project from DST, which is in the verge of closure. This is my original work domain, which I did my PhD, and then into kind of awarding PhD and all. One PhD only I taken in terms of biomedical recently, but that's all. I can quickly tell you the machines, how they have come. They were all retrofitted machines, old machine which I got in 2012 from old MREC culture. So we retrofitted, started using, students started. This is a micro machining facility. This is a finishing facility which has moved from my own PhD scholar and having 3D printing, developed this product development by using the same printer. And of course, lots of micro these measurement facilities, including look at this, those are from electronics. So I want my students, even mechanical BTech, everybody to know, understand the different powers which they need in welding, in mechatronics, in EDM, so that they understand this, they understand CRO, they understand DSO, and they are able to weigh it, measure it, the power, and like any other tangible things. Of course, lots of data acquisition software, CAD modeling software. You can talk about one CAE software copies I have for HyperWorks. As far as machine properties are there, we can go for this. So with this, I close with lots of thanks to you and your patience. Over to you, sir.
Yeah, it's excellent.
So finally,
Questions?
yeah.
Any questions you have? Sir, I would like to ask what the material you are using for AFOs.
Conventional material is polypropylene, sir, which people are using in most of the hospitals. But what we have tried doing is we have printed with ABS, we have printed with PLA. PLA is one material which is not having right strength, but its biocompatibility is very good. It's an organic material. But we are also trying to see with better material, this FDM printers, whereby we can actually print polypropylene. So polypropylene is the one which is needed most. But right now in my lab, I am able to do with ABS and PLA. That's the answer.
Have you dealt with that foot angle? Actually,
Yeah, definitely. Yeah, go ahead, sir.
so what the angle is you suggest for this AFO?
Foot angle for AFO. So it
Yeah.
first it has to be evaluated in terms of what is there. Say if you are looking possibly for the condition like drop foot. So drop
Yeah.
foot is one such condition, which is usually you'll see with lots of people walking, old age people walking. So they have this kind of situation whereby the foot drops. That means foot comes more in dorsiflexion.
Yeah.
And they strike, the foot gets striked on the ground. So even if they generally wear shoes, real leather shoes, so that it's comfortable, and still there are problems. So the solution lies in this kind of orthosis. So the requirement here is what is the kind of orthosis will be given by the clinician only, not by me or anybody, not by engineers, definitely never. And we should never attempt, otherwise they will get offended. The important thing is right angles and what kind of support they need, what kind of angles has to be there. We have to appreciate and try to help those doctors. So I am not replacing doctors. What I am trying to say is this, that the interventions of technology, wherever there are possibilities, can be involved in. They can be given with. So there are, even if you look at this particular case, this kind of AFO will have various, posterior leaf on ground reaction forces. Based on this, the different designs are there. So clinician only will give the angle. We will not give. We will only support and do in terms of the kind of faster manufacturing and customized manufacturing. Right, sir? Anything else? Any more question? So there's a question from Dr. Masood. He says, what is your opinion on patenting and keeping design open source as it deals with the value addition to life? Yeah. If one can afford, this is what one can afford. One can do this value addition. I mean, keeping it in open source, but it is not a opinion. I mean, there are different classes of people. So it is not necessarily anything which gets patented is always commercially exploitable. And my opinion doesn't matter much, because it is like I don't have that stage whereby I can comment something that, oh, I given this thing to the society or the work. So it depends upon when the right time comes. But there are people who keep it in open, the way we have talked about. We heard about this vaccination and all those things are going on.
Yeah, Professor Mali, actually I had that network problem. So I wanted that question that if you design that AFO for the patients having foot drop, you have to fix up that angle.
So,
Now,
yeah, sir. I got your question. What I'm trying to say, this is the fixing of the angle and the angle to be kept is done by the clinician, doctors. What I'm trying to help is, this is the right now procedure. The clinician comes, the patient comes to the clinician, they take a mold like this.
no, what is my question is, like if we use that AFO, so that creates problem while climbing the stairs,
Yes, it is.
because during using that stairs we have to reduce that angle.
That's true. So for
And
that
then
reason, there are, I think you say the hinge type will help. There are some hinge type AFOs. There are solid ankle hinge type whereby I think there are kind of flexibilities are given. So I'm not sure precisely because I have not done that kind of case study, that kind of empathy study, that what can be done. But I think there are some solutions available in market.
Okay.
Because yes, sir.
Definitely, I'll discuss with you. That's a pretty interesting area and a very useful area. So, any other question if participants have? Just see question in chat box.
So the whole idea is the customization here, how the technology can be used for customizing it. So in place of this, what we can do is we can follow this kind. So in place of this, we can follow this kind. So scan the patient's foot, develop everything in lab, do optimization, print it, and give it fast. That's the technological intervention. That's the work I'm trying to refer about.
Should we sum up this?
So there is again a question from Dr. Masood. He says, if there is any way that how we can keep the patent open source. As far as patent open source is concerned, I think patent process is, Dr. Masood, is like this. First, you will get a registration, it is awarded to you, and then when you have lots of people are there with lots of patents awarded to them, but they are not used to until unless somebody commercially exploits them. So what is the commercial exploitation? Say it is there in open source, it is there registered in open registry, public domain. So what happens? Those who are interested will approach you. Those who are interested will approach you, and there are agencies, we generally call them attorneys. They will come in between and they'll do all kind of technology transfer formalities with kind of weightage of this evaluation of the technology. So if this happens, okay, if you are given this to one NGO or one hospital, say some hospital comes that I want to buy your this particular technology, give it to us. So you can give it that particular time, you can give it out of free, or you can give it out of some token money, or it can be perpetual, and all kind of techno-commercial stuffs come in. So I am not sure, Dr. Masood, what are those legal points are there inside. Possibly I am not rightly able to tell you at this stage. Okay, so those technological people can definitely tell you, right? Thank you.
So
this was a question.
Yeah, you can continue.
Yeah, this was a question from Dr. Masood, and I think we talked to any more question, even in chat or anyway, we are ready to talk. Seems to be no question, then over to you, sir.
Dr. rahulrajchoudhary sir is having some network issues, although it was a very good session.
Thank you, sir. And I think if anybody has any comment, he can. Else we can close.
Thank you very much, sir, for this session. It was very informative.
All right then. Bye bye. Thank you. Thanks
Thank
for
you.
patient hearing.
Thank you, sir. Thank you all the participants.